The next property that we're going to take a look at is the basicity of amines. And the general rule of thumb, and it depends on the structure of the amine, amines will react with acids that have a pKa of 10 or less. And the reason that amines are basic is because we have the lone pair on the nitrogen. So let's just say, for example, we react this with HCl. We would definitely expect it to react because HCl has a pK of about -7. So what happens is the lone pair on the nitrogen will take the proton from HCl. We get NH3 plus and Cl minus, and this is an ammonium salt. Which is an ionic compound. So just for a couple of things to look at, let's just say we have, there's a common base, triethylamine. Now if you react that with a carboxylic acid, like acetic acid, we would expect that reaction to occur. So just a regular acid-base reaction, but the reason that we would expect this reaction to occur is because the pKa of acetic acid is about 5. Okay, in comparison, if we react triethylamine with just an alcohol, like ethanol, which has a pK of about 16. Well, 16 is higher than our threshold of 10, so we wouldn't expect any reaction to occur there. Now we want to consider some trends regarding the basicity of the amine. And it has to do with structure, kind of the same way we analyze structure of acids by looking at the conjugate base stability. Well, if we're thinking about basicity of amines, what we're essentially asking how reactive is the nitrogen lone pair? And the general rules we can use here, if you have electron donating groups on the nitrogen, that's going to make it more reactive, more basic. If we have withdrawing groups, it's going to be less basic. So just to look at a few simple amines. Here we have ammonia, methylamine, and dimethylamine. So we know that hydrogens are very slight withdrawing groups. So inductively, they're pulling electron density away from the nitrogen, kind of helping to stabilize that lone pair on the nitrogen, meaning this one will be the least basic. And then alkyl groups, they're very slightly donating. So down here on the other end, we have, you can kind of think of it as an extra punch of electron density toward the nitrogen and its lone pair, making it more reactive and more basic. So in this case, our trend would go in this direction. Another thing you can consider is resonance. So if we compare aniline versus cyclohexylamine, what we want to think about is the availability of that lone pair to react with an acid. Well, in aniline, the lone pair is tied up in resonance. Versus in cyclohexylamine, this lone pair is just sitting there on the nitrogen, 100% available to react. So that means this nitrogen's more basic and the aniline nitrogen is less basic. Okay, now we also talked about aniline basicity earlier in the semester, and again, just as a refresher, let's say we have a group on here. If the group is electron withdrawing, that's going to pull electron density away from the nitrogen, and that will decrease basicity. And if the group is electron donating, that will increase basicity. Okay, another trend that goes hand in hand with resonance, or just a comparison here, is if we compare the nitrogen of an amide versus an amine. This lone pair on the amide, it's tied up in resonance with the carbonyl. And because of that, it's not nearly as basic as the amine lone pair. The final trend we'll take a look at with basicity is hybridization. We were able to use hybridization to predict relative acidities, and we can do the same thing for basicity. So let's compare these three things. Okay, as far as the hybridization goes, we have 4 groups, that's sp3, 3 groups around the nitrogen, sp2, and 2 groups is sp. So let's look at the two extremes, sp3 and sp. sp, 50% S, 50% P character. sp3, 25% S character. It's a 75% P character. Now remember the way to think about this. Let's go down here to the far right where we have the most S character. We have greater S character. Remember that the S orbital is closer to the nucleus. Which the nucleus is positively charged. So being closer to the nucleus and that nucleus being positively charged can hold those negative electrons more tightly. If those electrons are held more tightly, they're not as available to act as a base. So this one's the least basic, whereas in the sp3 hybridized nitrogen, there's only 25% S character. Those electrons aren't held as tightly. So this one is the most basic. Now we spent a lot of time here looking at the basicity of the nitrogen and converting it to the ammonium salt by reacting with an acid. And one of the reasons we spend so much time looking at this is because it's an extremely important process in the pharmaceutical industry.